This video talks about VQ mismatch. If you want to follow along with me, you're welcome to do so by going to page 566 of First Day 2012. Okay, so let's orient ourselves with this graph first. On the y-axis, we have flow, milliliter per minute, and on the x-axis, we have base here and the apex here. So what happens at the apex of a lung? Let's forget about this graph for a second and let's focus on what happens at the apex of the lung. At the apex of the lung, air tends to move to the tip of the lung. Why? That's because air is lighter, so it tends to move up. Where blood is heavier, so it tends to move at the bottom, at the base of the lung, right? So we can say that the apex of the lung gets too much ventilation, more than it's necessary, and the base of the lung has too much flow, more than it's necessary, right? But now in the middle region is the area where the ventilation and the perfusion is, close to ideal. Not too much ventilation, not too much perfusion, they kind of balance each other. Ideally, ventilation perfusion, the ratio should be 1, but usually it's 0.8. At the apex, it is about 3. At the base, it's about 0.6. So in the middle, we have the closest to ideal as possible. When we are exercising, what's happening to our arteries? The arteries dilates, okay? So as a result, there will be more perfusion rather than ventilation. Ventilation would be the same, right? The same amount of air is coming to the lungs. So at high level of exercise, at the apex of the lung, it can also has the ability to reach that ideal ventilation perfusion ratio. Okay, now let's see this graph and let's see how this graph relates to our concept. So we can see that this is the apex, and we talked about how the apex of the lung is going to have more air or more ventilation, and we can see it from our blue graph. The blue graph is touching almost the x-axis, right? And the VA stands for ventilation. Okay, the apex is going to have more ventilation, which makes sense, and at the base, ventilation is going to be much less. And the green line, at the base of the lung, the flow is going to be it's going to be highest, right? See how ventilation is so much lower than the blood flow? The blood flow is going to be highest at the base, but it's going to come down as it's going to move to the apex of the lungs, right? So that's what we see in this graph. And here, where the two graphs cross, that's where we are looking at where the ventilation perfusion ratio is going to be close to 0.8. At this point, we're going to have 0.8, right? Ventilation perfusion is going to be 0.8, almost approximately 1. Now let's look at these values and let's it should correlate to what we have already learned so far. We can see that, let's do apex first. I like to do apex first. So at the apex, we see that the oxygen is greater than 100, which makes sense because there should be way too much ventilation, and that's what's happening here. And carbon dioxide is going to be less than 40, which makes sense because the blood flow should be less than ideal. That's why even the carbon dioxide level is going to be less than 40, because 40 is the normal, right? That's how much it should get out of the lung into the alveolus. But less than 40 is at the apex because less blood is going to the apex. The pH is going to be 7.4, greater than 7.4, which is a little basic. That's because there is less carbon dioxide, making the pH basic. And the VQ ratio is going to be greater than 0.8. And why is it going to be greater than 0.8? Because on our numerator, we have a VA, which is going to be higher. So when the numerator becomes higher, the result is going to be higher. If the denominator was higher, the result is going to be lower, which happens right here. At the base, the purple region reflects the values for the base. We can see that the flow is higher, so the VQ mismatch is going to be less than 0.8. What about the rest of the values? Here we see the PO2 is going to be less than 100. PCO2 is going to be greater than 40, and pH is going to be less than 7.4, making the blood a little bit acidic here and a little bit basic here. So you get the idea, right? Now let's look at the middle region where it should be ideal. Let's look at our ideal values. We see that P is equals to 100, perfect. PCO2 is 40, perfect. pH is 7.4. Perfect. So it correlates to the story that we have built up so far. So now that we understand the concept, let's do a little more. Okay, so we have VQ, okay? Let's imagine that, let's say the V becomes 0, okay? Let's say V becomes 0 and let's say Q is, I don't know, let's say 10. What do we have? What is the answer? 0 divided by 10. Now 0 divided by 10 is going to be 0. What does that really mean? When does ventilation become 0 and we have a value of perfusion? Ventilation becomes 0 when there is an airway block. Okay? So if your VQ mismatch is 0, that means there is an airway block. Let's go to the other one. What about VQ where Q is 0, let's say ventilation is 10. These are just, any number. I'm not, coming up with a specific number. These are just any number. I just want to show you how mathematically it makes sense. So if flow is 0 and ventilation is 10, we get an error message or infinite. So this value, when we get an infinite value, then we know when is flow 0, when there is a vessel, complete vessel block. Okay, complete vessel block. Okay, so just wanted to show, put it out there. Another thing I want to talk about is at the apex of the lungs. TB tends to go to the apex of the lungs because there is more air and it can flourish, and TB needs oxygen for it to flourish, right? Another concept just to throw in there. So now let's go to our first question. Now let's look at these two graphs. These are the two different options that we have. And the question says that which of the following two graphs showing us a perfect relationship of blood flow and VQ. Okay, so let's work through it together. So we know, even without looking at the graphs, we know that at the apex there is flow. So the flow is the one that we are going to relate to first. So we know that the flow is going to be highest at the base and lowest at the apex. Okay, so where do we see flow high? So we see that the flow is high here. It's pretty much high here too, right? I mean, it's relative. Okay, so this line seems to be okay. But what about VQ? Where is VQ high? What did I say about VQ at the apex? We said that the VQ at the apex is wasted VQ. It's about 3. And VQ at the base is about 0.6, right? So VQ at the apex is going to be higher than the base. So we can see that at the base, here in this graph, we have VQ high. This cannot be. VQ is high at the apex. This is true because it's supposed to be around 3. So among these two graphs, this would be the answer of choice.